I am one of the 3D physics programmers in Unity. We just hired a new guy recently. Melvin is working on the 2D features. And today I'm going to present to you some of the 2D and 3D physics features and best practices that are applicable to the 5X series. First, a little bit about 2D, some performance tips, and some of the new features introduced, and fancy new colliders and joints. The underlying middleware behind the 2D physics in Unity is a middleware called Box2D. And Box2D expects your colliders and rigid bodies to be mostly unchanged. So you have your setup in your scene, you compose your rigid body to be a whole thing, and then you play your scene, let all the forces apply, things tumble around, and everything is nice. But it kind of doesn't expect you to start changing the colliders, modifying it, scaling it. Of course, you can do this. If you're making a game where changing and mutating things is important, then you should just beware of the cost of doing it. For static colliders, there is a little secret thing going on behind the scenes. They all have one shared body. So this means if you move a static collider in 2D, we actually go in and transform all the vertices of that collider, if it's a mesh collider, and we do that every time you move it. Of course, if you really want to, you can do it. But if you want to move objects, you should really attach yourself a rigid body 2D and make it kinematic. And this also happens every time you put in a new static body, then we transform all the vertices. And the reason we transform it is to make the collisions even faster. So if you start touching it, then we lose that advantage. And the same thing can sort of be said for modifying the transform on a 2D rigid body, more specifically the game object. If you touch the position on the game object, we see it as a teleportation, and we don't really keep a fine track of where it's coming from and where it's going. So you write to the position, we're gonna say, oh, let me just find out everything that's around this of your rigid body and rebuild all the contacts with everything around it. And that could be expensive. Likewise, if your rigid body is made out of a tree of colliders, if you have child colliders, and you start modifying them or recreating them or scaling them or adding to them, then we rebuild all the colliders of your rigid body, so that also incurs a cost. The same thing is true if you rotate, scale, resize, or change the radius of your colliders, then they will all be rebuilt. In the 4X series, we had some issues with performance in 2D physics. People were getting a lot of stalls because of the garbage collector we're running, because of all the waycast queries, all the box queries, all the circle queries provoked heap pressure. And to fix that, we introduced a series of non-alloc function calls that use a user-defined buffer prepared by you guys. And so we write into that buffer until it's full, and we completely bypass all the garbage collection issues. And of course, you have to prepare this buffer in advance, and you can do this when you're creating the objects that should store the content and whatever. That's all up to you. Another thing introduced in 5.0 is knowing if two colliders are touching each other, or if a layer is touching a collider, or two layers are touching. And this is applicable when you have a character in 2D, and the character is walking back and forth, and it might be jumping, or you know if you should trigger your jumping animation or not. And people have been doing new overlap tests to find out if they are overlapping the environment but now you can actually just call a function and let you know if you're touching another object or if you're touching like a ground layer or another layer. Okay, 5.1. Similar to in 3D physics, where you can constrain the horizontal or the vertical movement of an object, you can also constrain the horizontal vertical movement of an object in 2D, and you can do the same for the rotation in 2D. And the rotation in 2D was renamed from fixed angle to fixed rotation C. So if you have some old examples, then you should just be aware that this has been updated. However, you should be aware that once you start locking all the positions, we do a little bit of compute work to make that stay the same. So if you lock all the positions and the rotation, then basically you have frozen your object, and you should just switch to like a static collider or a rigid body with a kinematic property on to make that go even faster. Okay, so in 5.3, which is coming out in December, and Pro customers already have access to this, there is a series of new joints coming on. And the first one is the fixed 2D joint, which maintains the relative position of two objects, of two rigid bodies, when you turn on the joint. So you can move some objects, turn on the joint. They are locked together by a very stiff spring, and you can adjust how that spring behaves. If it has some wobbling with a damper, or it just follows. And then you can deactivate the spring, move the object, and then activate the spring again, and they will stay locked together. We also have a slightly different version of this that also takes two objects, but it is more like a motor. So if you rotate one object, a motor will be applied to the other object to get the same rotation. And likewise, if you move it down, another force will be applied to move it down. And it goes both ways. So if you tell the other object to move up, then the force will be applied to moving it up. So you can use this to slowly align objects with each other and follow each other. Then we have a thing called a target joint 2D, which is basically a sort of a follower. It just works on a single rigid body. And you can give this, this joint a target position, and it'll then use a spring. So if you have a rigid body, it can chase around some reference position. And you can, of course, have it wobble if you want the spring oscillating or whatnot. So you can use this to follow targets. We also have a friction joint, which you can use to simulate different kinds of drags or other things that slow your objects down. It is also a motor, and you can use the you can set the force and the torque independently, so you can decide if you only want things to be slowed or things to be the rotations to just go dead. And then we have the buoyancy effector. And the buoyancy effector is basically a set of building blocks for building small fluid flows, building small water dynamics scenarios in your 2D projects. It incorporates buoyancy into your rigid bodies and your colliders. It allows you to express flow directions, and it has drag forces on your bodies in the water. The way that it works is the fluid mass itself, a collider will be set up that represents a fluid, and that fluid has a density. And then you have your colliders, and now you can set a density on your colliders. And if the density of your collider is lighter than the fluid, like a tennis ball is very light, and if you put it inside the fluid, it will flow up because the tennis ball has a lighter density than the fluid. But let's actually see how this looks. So you have a few different colliders. They have different densities. And now we start dropping different bodies into the water. And you can see that some of them float above, some of them are dragged along the bottom. And the bottom, you can see the flow rate is different. It goes much faster. And on the green container to the left, you can see that the density is much higher because all the heavy objects are pushed up. Melvin will be very happy to hear this. Yeah, and this is it's optimized so it works well with the existing workflow and it doesn't cause super big slowdowns. It also works with joints, so if you see the balloon on the right, the small rotating friction force drives it to the right. It also defines a high water level, which is the high water level. So if things float, we can vary it, we can drop it, and it works seamlessly with the rest of the simulation. As I said, the colliders, any 2D collider can be used for buoyancy. So here we have all kinds of different objects, and we are raising and lowering the high water line to make the objects flow in and out. Okay. So that was a little bit about the 2D physics. For the 3D physics, I first have to issue a little bit of an apology because I'm not going to go through a lot of the wheel collider. I know that the summary said that, but I cannot take expert questions since Anthony is the top vehicle collider expert, but I will be covering a few things that we have improved with the wheel collider. So first, I'm going to talk a little bit about general tips and tricks. Then some common features we've seen with the joints, different joint usage scenarios, ragdolls, etc. And then some of the new features and what we're going to add in the future. So, a lot of people, when they add a collider to the scene, might not know that is what we call a static collider. This means that the collider does not give velocity to the world, and other objects cannot see this collider as ever moving. In Unity 4, we usually have some problems with people moving static colliders around, and that caused a lot of performance spikes. This has been fixed now, so you are free to move your colliders around. However, I do not advise you to do that because the other objects in your world cannot see that your colliders are actually moving, because static means does not move. So if you find out that you are moving static colliders, and we do give out a few warnings on this, I think, add a rigid body to your collider and set it to kinematic true, and then you should be completely good to go. So we add a rigid body to your static collider. We set it to kinematic. And then you say, okay, let's write to the transform on the game object because that works really great. Unfortunately, like in 2D, when you write to a transform on a rigid body, we see it as a teleportation of the object. We don't know that when you move it just a little bit, that you actually mean that it should move in that direction instead of magically appear in that direction. Of course, you are still free to set the transform position whenever you want to shuffle your world around, you're streaming things, you're adding a new room that your user can't see, whatever, then it's totally a great thing to set the transform. However, when you want to move your dynamic bodies that are kinematic just a little bit, you should use the move position, move rotation, or move functions, because these functions actually tell the rest of the physics system that the object is moving. So imagine you have some kind of platform. People have that sometimes. And then you have like a small box on your platform, and then you are moving the platform. Normally, you would expect the box on top of the platform to move with it. However, it is the friction between the moving platform and the box that actually moves the box. It's not the platform itself, it's the friction. And the friction comes from the velocity. So if there is no velocity, the box on top cannot really be moved properly. So you should make sure to call these move position and rotation functions on your kinematic bodies to communicate velocity to the rest of the world. Okay, joints. Joints and fast-moving rigid bodies. Rigid bodies. So these are like common issues. It's not actually your joints. Some people have issues with a rigid body using the freeze rotation functionality, and some people have issues with ragdolls and different kinds of issues. And I'm going to go through all of these categories. Okay. So one sort of underlying issue with PhysX, which is the middleware that's used in Unity, physics middleware, is that there is one fixed update delay between the physics system discovers something is in contact and it actually can apply the forces to enforce that contact. What this really means is if you have a fast-moving object that is right in front of a wall or any kind of obstacle, and you insert it into the world, you would logically expect it to be blocked by the wall. However, if it moves fast enough just to jump through the wall, it will actually do that. And there's not a lot of things you can do about it. Of course, the first thing you should do when you have very fast-moving objects is to enable the continuous collision detection. This is a system that behind the scene does some sweeps. It extends the bodies in time, so it can figure out when the bodies are colliding and apply a correction force to them. It has some restrictions though. When the CCD system is running, it is still one of the best alternatives, it will not consider the angular velocity, the rotation of your objects. So if an object is rotating really fast, and it's rotating fast enough for the CCD, or it's moving fast enough for the CCD collision to trigger, then we won't consider the rotation of the object as it is moving through space. It'll just be the linear position. And when we find an impact, we won't consider the rotation of the two bodies, the rotational velocities of the two bodies either. So there can be some downsides to this, even though it's a good choice. And you should totally enable it as as your first sort of path to resolution when you have really fast-moving things and they don't behave properly. Another thing you can do, on the other hand, is increase something called the contact offset. And the contact offset is a number that tells the physics system how far out in space it should start searching for contacts. So it's sort of effectively a radius on every collider that tells the physics system how far ahead should we start doing the collision detection, and of course the further away you can find contacts, the earlier you can detect them. So if you have objects that are moving fast, you can increase this value and it will discover the contacts earlier, so you can have them resolved on the next fixed update. It has a cost though, so don't just like crank it up all the way on every single object in your scene, because then everything has to collide with each other, and things go a bit slower. It also have a slight drawback, that because contacts will be created earlier than they are per default, then you will have maybe slight changes in the way your collision responses, because contacts can move slightly because they are detected at a different point in time. So you cannot just take a level that's very finely tuned and crank this all the way up and not expect anything to change. But it's still a good thing to consider. So the same things, the same rules for the ragdolls apply. If you're inserting a ragdoll and you wanted to collide with something, you should really make sure that you insert it into your world before that you actually are touching the walls. And a way you can do this is you can make some hidden triggers on your characters that detects walls or whatever, or you can have like your walls with like an extra thick trigger on top of them that can trigger your guy to go ragdoll. Because if he is moving really fast, probably you cannot see that there is a fixed updates difference, but it will make a difference to your game because people won't actually tunnel through walls. Another thing that is worth considering when triggering the ragdolls and solving questions, solving issues with them, is when you have a CCD-enabled rigid body that's going at high speed, and you have another body jointed together to it. Then the CCD system, it will resolve the impact and ignore the joint. So on the next frame, the joint will be completely violated, and then it can do the famous exploding thing where some things can fly apart, and that's not always super nice. I'll be talking a little bit later about what you can do with joints that are violated. Okay. Some people are also using freeze rotation to make rigid bodies like not turn around, and sort of sometimes you also use them to simulate 2D-like behavior in a 3D environment. This is in local space now in Unity 5, where in Unity 4 it's in world space, and this is because physics has changed the way that they resolve constraints. It is implemented as infinite inertia, which means that sort of the direction of rotation wherein you want to lock your object, the object sort of become infinitely heavy in that direction, and so there is no infinite force that can actually rotate it. However, all these infinities sometimes can go a little bit waggy, and we can end up doing something that is akin to dividing by 0, which is like a bad thing. And a way to get around all of the scenarios is to disable something called pre-processing on the joints. What the pre-processing is something that makes the joint more accurate. It makes it faster to solve and requires less iterations. However, it becomes like very sensitive to some conditions. And this is especially true for ragdolls. So if you're trying to constrain things into one or two directions of rotation, try to disable the pre-processing if you have problems. And another set of problems that can come up is they stack objects. Everyone loves a nice stacking game with some cubes. But then what they will see is the objects will start sliding around each other where they should really be going to sleep. And what you can do about that is you can jump to the edit and physics menu, and then you find the solver iteration count, and then you just crank that value up. We've seen that sliding object and sort of some jittering examples as well, they will be resolved around 20 to 30 iterations, and it doesn't cost you a huge performance impact. Even though like the number is 5 times higher, it won't actually be 5 times slower. So that's definitely worth looking at. A third thing that can happen once you start freeze rotating is that you will get a crash. However, it's a very, very, very specific scenario. It is what we have detected for the hinge joint, and I'm telling you now because we don't have a fix, and the fix will take 2 months to get out, and da 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 da. But the hinge joint is something that rotates only during along one axis. So within the hinge joint itself, there is already 2 degrees of rotation frozen because it can only rotate in 1 degree. So it makes not a lot of sense to apply a freeze rotation to a hinge joint. And if you want to constrain the hinge joint completely, then there is actually no joint, and you should just make a fixed joint or do something else. So if you have issues with the hinge joint, make sure you don't use freeze rotation with it. Okay, ragdolls. Ragdolls can be a little bit tricky, and sometimes they require a lot of tweaking. We have set up the physics, the ragdoll wizard inside Unity to produce like pretty decent ragdolls, but it's not the best solution that one can think of, and we want to improve the ragdoll building functionality in the future, and also how it integrates with the rest of the systems, the human systems in Unity that uses ragdolls. We don't have a timeline for it right now, so I cannot say anything in particular. Okay, so one thing you guys should be considering when you're tweaking your ragdolls and maybe debugging them is making sure that all your body parts have about the same mass. Different parts of the body, like the torso and like the upper arm, the difference can vary about like a factor of 2. That's kind of okay. The problem is the bigger the differences between the masses of the objects, the solver will start moving the objects at different speeds. So if you have a very constrained environment with like a lot of guys that have ended up in like weird yoga poses and like a door is closing on them and whatever, then you can get jittering because things are not being solved in exactly the same ways. So please go for like equal mass distributions. Something to consider with the joints is that you should not have joints with a too little degree of movement. And what we have set the default joints to is to have at least 5 to 15 degrees of free movement. And lower than that, we have found it can also cause issues. And I think most of the time we actually correct the joints to be like at least 5 degrees of freedom when you instantiate them. Otherwise, we got bad results with it. So please keep this in mind. If everything goes wrong, like if your ragdoll starts getting completely torn apart, and you can see that the joints will not actually be resolved in a satisfying manner, you can enable what is called projection on the joints. And what the projection stuff does, it's just to take your different body parts and it just glues the body parts together and completely ignore the physics. But at least your body will stay together. that can be useful if you have like a CCD, the continuous collision detection I talked about earlier, and you have a guy who slams into a wall, and the system pushes him out, reduced to a pancake, and then the joint solver actually has to unfold the whole figure back into something that looks like a human, but everything is completely torn apart, all the joints are completely violated, and then you can use this projection stuff just to put everything back together. One thing that also has changed with the Unity 4 and Unity 5 is the way that the physics internally solves or prioritizes constraints. So if you have a human being that touches a wall, now the wall will actually have a higher priority than the joints inside the human being, and that can lead to changes in the way like your ragdolls are. Your ragdolls are getting resolved. If you have environments with like a lot of clutter and a lot of moving parts, then the solver will actually give a slight different prioritization to the way the things are going to be solved. Another funny thing with the ragdolls and the constraints that we are using is if you have people in very stylized, tight positions, and I would like to have a picture of it, but it's like someone typically holding a machine gun like this. They have their upper arm tied into their chest. They have the other arm following the chest and the arm closely here. And maybe you have like a giant machine gun or a bazooka or some crazy banana gun in your game. And at the same time, it's all facing the chest and whatnot. And what can be an issue here is actually all the capsules of your ragdoll can be overlapping if you headshot the guy while he is standing this and looking very, very serious. And what will happen is all the capsules will suddenly be inserted into the world. They will be overlapping, they will be colliding, and they will be pushed apart by the solver, and your character will like fly out like this. And if you're making like a realistic kind of game or a non-joke game, then probably you want to avoid that. And you can do a few things to tone this stuff down. For the first thing is like slimming down your colliders. And preferably you test out you take your guy, you put him in your like extreme animation poses, and then you just see if the colliders are overlapping, and then you can sort of trigger them a bit and see if like, is this something I want, is this okay, can we raycast against the colliders on like a good average basis, whatever. Another thing you can do is you can take a look at all your joint limits, especially the elbow limits and the twist limits here in the arms and the limits here in the shoulder. If they are not wide enough, like crank them up, double them up to make sure you can get these very, very wide things, wide action going. And the third thing is if tweaking these things aren't quite enough, or your colliders, they work so well in another scenario and this is not so super important, you can tweak what is called the max deep penetration velocity on the rigid bodies, and that is a value that's used by the physics solver to push the bodies apart when they are overlapping. And if you tone this down, then they will sort of smoothly go out of each other instead of popping out of each other. And you can tweak all these sort of variables independently, see how it matches with your animations, and see what kind of results you're getting. Okay. Sometimes when I create a pile of 20 men and play around with them, they don't like it. They start jittering everywhere. And what you can do to sort of help that situation again, edit physics, the physics manager, and set the solver iteration count up. And we have also seen that make a difference. And the reason I'm saying this, and that it's not just a part of we just change the default value when we ship a new version of Unity, whatever. It's like we don't want to like change the performance characteristics of your game, and we don't really set this per body. Maybe we can set it per body. I'll go investigate that. But set the solver iteration count up if you are working with Ragdolls. And in the same general piece of advice that applies for joints, please don't set the transform of the ragdoll body parts directly. Like if you are grabbing a dead guy, maybe you want to move his hand. Of course, you can attach a joint to the hand and move him that way. People's first implementation will probably be to write to the transform directly, which will do this whole joint violation thing. And you should really use the move position and move rotation set of functions instead, which will tell the joint about the velocity in which you're moving the objects. And that'll help the joint solver get everything solved together. Then, a third thing again is if you have like very strange scaling values on the game objects that contain your joints, please try to just make them normal just for a short while. Like negative scaling is bad because it's inconsistent across different places in the engine. And if you have some joint issue, like check your scaling values and just set them all to 1 and just resize things to be the same, and just do this for debug investigations, because it can sometimes be a problem as well. Most of this sort of advice and guidelines and whatever, we actually have online. Unfortunately, not a lot of people know about it. But it is here. It's part of the manual, and we call it the Ragdoll Stability Guide. And of course, the tricky part in that is it also works for joints. But both for Ragdolls and joints, go have a look at that. And we also have, as part of the upgrade guide, different issues we found with all the games that broke when we updated to Unity 5. So check these online resources out. Okay, new stuff. Something people asked for a while was knowledge about the impulse in collisions. And we have had that for a while, but now we had the value, but we didn't write anything to the value. And now we gone and fixed that. So now you can tell on a collider basis in a collision how much energy, how much impulse did the solver need to push these two objects out of each other. And the way we report that to you is that we only look at the first 16 contacts in a set of collisions, which is usually by far enough to describe the whole collision. And then we sum it up, and then we pass it back to you. We don't yet expose each contact individually. We know people would like to have every contact available on the scripting side to inspect them themselves. Well, and of course, collision.contacts is available already. You can go and read it. But there is a lot of garbage collection issues with it, which causes people to not use it at all. Which is, of course, an unhappy thing. And we have plans to expose a user buffer API, and so you can fetch the contacts out of the collision without having any garbage collection overhead. And I'll briefly mention that later. but I will tell you that we don't have a very, very specific plan for it, but it will not be in the far future. So what else have we introduced? Well, we introduced this concept if like a raycast or a capsule cast or sphere overlap or any of what we call the scene queries, we want to control on a per raycast basis if your array actually collides with triggers in the scene. And the reason we want to do that is because people are sort of running out of collision layers, and modifying the whole collision layer system in Unity is actually like a big task. We have guys working on it right now, but it won't be ready tomorrow or next month. So people who want like fine detail collision information with triggers, and you usually want that if you're building your own character controller. Usually when you have a character controller, you want to sweep ahead in your environment, and you want to find something that is static or rigid or anything that will block your character. And if you have not annotated all your triggers with all the correct collision layers, then your sweep will hit the trigger, and you would have to like manually discard it in all your callbacks, and that just it leads to a lot more code that has to be modified. And it's better just to be able to go to your capsule sweeping functions and say, hey, look guys, let's just not use the triggers for anything, because we're not going to use them. By default, it uses the global value in the physics manager, the query hit triggers, which was the old raycast hit triggers value. And now you can just say, no, let's ignore it, or let's collide with that. Boxes. Who doesn't like boxes? We have boxes now. People have been asking us from time to time if they could check overlap with a box, and we added that to the latest alpha. So if you're a pro customer, you can use boxes in Unity for overlap testing right now. Yes. And of course, we had also had a lot of questions about garbage collection and raycasts, because we know that people have seen it as like prohibitively expensive to use the raycast in Unity or to use Unity at all because of the garbage collection issues. So all the different raycasts and boxes and spheres and yeah, the boxes I just presented, they all have these non-alloc functions, and it works the same way as with the 2D physics, that you prepare a buffer with all the results, and then we write into that buffer, and we bypass the whole garbage allocation system. Something else that we have recently introduced is something that assists the wheel colliders, actually. Now you can control on a rigid body independently how the center of mass is updated and how the inertia tensor is updated. And the inertia tensor is how it tells how heavy sort of the rigid body is when it moves in each direction. So for cars, this is important because when you scale the cars, you update the distribution of the colliders, which can be done independently of the center of mass of the car or of the colliders themselves. So if you start setting the center of mass yourself, we say, hey, now you're in control. The same thing with the inertia tensor, and the two things are independent. So you can control this all you want. And if you say, okay, no, now we're going to add some new colliders, I want my center of mass rebuilt automatically, or I want the inertia tensor to be rebuilt automatically, you can just reset it, and we'll go back to taking care of it for you. Yeah, so the wheel collider support is still improving. Anthony is working on that, and he resolved some scaling issues recently that he wanted to make sure that you guys know about. He's going to keep working on the wheel collider. And we have also been working a bit with the particle guys. We had some issues with particles falling through big terrains. Now we modified the particle system to prioritize the terrain colliders over all other colliders. So the particle system itself has like a user-defined max-sized buffer on how many things it can collide with. And it will try to fill that buffer as much as possible with terrain colliders. And then if there is space left, then use the other colliders. Of course, you can tweak this yourself now. Hinge joints. They are so simple, aren't they? Oh, yes. People have been asking me on the past 2 days here on the show floor if the target velocity of the hinge joints would be updated, and I can tell you they are fixed now. So you can have like from minus infinity to plus infinity target velocity on the hinge joints. What I've been working on is to make sure that property for property, the hinge joints are now behaving and they are oriented in the same way as in Unity 4. I have used my best programmer art skills to make this illustration for you. Below you see the pink box. That is a box with a rigid body and the hinge joint on it. So that's the body with the hinge joint. Slightly above that, okay, you can't see my mouse. Okay, in between the gray box and the pink box, you see sort of a little orange thing pointing to the left. That is the axis of the hinge joint, which the two bodies will rotate around. And what has happened now and consistently within the hinge joint is that the pink body rotates with the left-hand side, which means it goes clockwise. If you set a positive target position, then it will go the left side around it. And the same for all the hinge values, the hinge limits. They will all go clockwise around it. And on the other way around, on the connected body, on the hinge joint, the gray one, it will go counterclockwise. So if you freeze, if you make the pink body kinematic, and you let the gray body be movable by the hinge joint, then it will see everything as being counterclockwise. So it'll be opposite of each other, but it'll be consistent now. And the same for when you get the angle on the hinge joint, it will rotate, it will return you the angle in the same orientation as the bodies are and as the target position are, and it will respect plus 180 degrees and minus 180 degrees. Okay, so the sort of the loose roadmap I sort of can give you that we're working on, because we have really been fixing bugs like all the time for the past 11 months. What we have first on our priority list is the character controller. We know that it's climbing around rigid bodies, and we have some fixes going on right now to help you get the Unity 4 behavior back. Anthony keeps working on the wheel collider. We have some fixes coming as well for the on-trigger stay. Like we have issues at least when you resize colliders, you don't get a symmetric on-trigger enter and on-trigger leave callback, on-trigger exit callback. And we have fixed that now, and we'll keep looking at the trigger stay issues. We know people want to have issues with sphere casting against scaled meshes, and we have fixes coming in for that as well. We know people having issues with threading performance on Android devices, and it's also something that we are actively working on. And then we're gonna work on regressions as well. So that's just a very, very, very short list of the bugs we're working on. So like for short-term versus long-term features, our short-term is around 3 to 6 months, and our long-term is let's look in 3 to 6 months. What I really mean is we have focusing a lot on solving bugs, and now we are going to move in a fashion where if we're not doing a bug, we're looking at features and saying, okay, how much will it benefit for us to work on this for like 2 weeks? Can we give something that is a positive benefit back to people? And that's how we're going to prioritize. So in the sort of short to medium future is a visualization, a debug visualization for the collision geometry. We find that it's very hard to see which objects in your game actually have collision on and where the collision is, and how do you get authoritative information about that. And it's also especially helpful for us because it helps us find bugs faster. And what it does, it just provides you a simple overlay on the scene view. It will highlight bodies when they're moving. It will categorize them by color, so they're easy to recognize. It supports the very large terrains that Unity can do, and it allows you to edit the terrains in real time, and you can still update them. And you can see, like, per triangle on every single object where exactly is the collision. So you don't have to like guess where things are colliding. And if you're aligning stuff with terrain, with the height fields, then you can know exactly on which side of the triangles you are putting your objects. Yeah. And we want to release like a test version later on this year. We also know that people have a problem with this this annoying warning saying that we don't support non-convex meshes for the rigid bodies. And basically what has happened is NVIDIA have removed the support that enabled people to use triangle meshes for the collision detection. We're very sorry that that happened. But it's most of the time people can work around the problem by cutting up the meshes themselves. So because of people can work around problems, we prioritize it slightly lower than problems where people have no workaround about. Stuff that is on the in the C++ side or on the trigger side or the physics side where you don't have any control. But we want to be able to for you to have a mesh, and when you're importing the mesh, at least initially, we will offer you an option to slice up the mesh automatically into convex parts, so you can use them with the mesh collider without a lot of problems. What else will we do? We want to upgrade to physics 3.3.3 because we get more collision detection fixes. There are some things right now that causes objects to jump when they shouldn't. We have some problem on Android from the threading behavior that has also been fixed, and we want to integrate that. We want to do different small things to reduce the garbage collection, and this collision contact that will be outputted to like a user-supplied array is also something we plan on working on. And so lastly, we wanted to improve error messages because the way physics is integrated is like sometimes we throw away a whole bunch of error messages. And I mean, no one really likes looking at error messages, but if you have a problem, they can be really good to take a look at. And we want to enable this editor-only or development player-only build of physics that outputs a lot of the internal errors in physics. So if you have something really weird or a crash, then you'll at least be able to know and react and tell us what's going on. And of course, in your real final game player, we won't actually ship this. But we won't change the behavior either. They will behave exactly the same way. Okay, so this is my presentation on 2D and 3D physics. Thank you for listening. We have like 4 minutes left. If someone wants to ask a question, they're welcome.
Hi.
Hey.
You mentioned that when you're using CCD,
Yeah.
you're no longer at high speeds taking into account the angular velocity of the object.
Yes.
So would that mean if I'm working on something where you are swinging a sword very fast and I choose to use CCD, the rotation of the sword is then not considered, and so the collision would be way off?
It will not be way off. It'll just be a little off. It is actually a very interesting problem you're talking about, because it is the same for flippers on a pinball game. They rotate very quickly around a pivot. And it is sort of very tricky to solve, because the only real way that you can solve this is just by cranking or lowering your fixed update step and get the linear movements, just get them finer. That's one way of doing it. Another way of doing it is like saying, okay, I predict that the average, the average orientation of the sword, even though you start the sword like this, the average will be like this, and then you sweep it from up here to down here. It's not super satisfying.
Also, thank you. Also, would you recommend that if I am swinging a sword then and I choose or choose not to use CCD, since you said that the hierarchy causes a problem as well, that I don't start the animation of the sword swing from the arm itself, but
that's only if whatever you touch with the sword will knock the sword like back a lot, and like it will, if the high movement causes a response that completely rips the ragdoll apart, then it's a bad thing. But I think in your case, increasing this contact offset, it'll be enough, because you basically probably just want to kill the guy, or do you want to, yeah. Let's talk about this afterwards.
Yeah.
Okay,
Thank you.
Next guy.
Excellent talk, brother. Awesome stuff. What a great way to end the conference, and the buoyancy had me giggling, and it's pretty awesome. I use the solver iterator count, or the solver count thing to solve a lot of stuff. Mm-hmm. And you mentioned upping it up to 20 doesn't hit you so hard on the performance. Can you talk a little bit more about that, and why does Unity set the default so low then?
Yeah. Well, I think the default is just like historical reasons. Like we just had this in Unity 4, and we just carried it over. And then because of the joint solver was rewritten, we just kept the same value. And of course, we don't want to mess with people's performance. But what this solver iteration count does is that it takes, when you have a pile of things and they are sort of all touching each other, everything has to know about everything to get a correct solution. And what the count does is it tells the solver how many times it sort of can go back and forth and distribute the energy between all the colliding objects. So it smoothes out all the collision energy, but in a physically correct way. But it doesn't have to redo any of the collision detection, and that's why it's fast.
Awesome, thank you.
Yeah, we have 30 seconds, and yep.
The new 3D colliding with the 2D.
3D colliding with 2D.
Yes. What version is that going to be with? Or
that is a good question. I know that we have talked about it, but I don't know when it will happen. I know that the particles will start to be colliding with 2D really, really soon, but I cannot tell you anything about the physics. Okay, thank you for coming. Enjoy.